Hey there, Gregory Carlson here with the Calculus Building. We just proved the product rule, so let's do a few examples. So let's find the derivative of y equals x to the 4 times x to the 7. I'm going to do this two ways. I'm going to use the power rule, and then I'm going to do the product rule, and you're going to see that it equals the same thing either way. So let's do it with the power rule first, which might be a little simpler actually. That would be the same as y equals x to the 11, because you can do x to the 4 times x to the 7 is x to the 11. And now doing the power rule, we would have dy dx equals 11x to the 10. Okay, so pretty easy to do with the power rule, but let's just show that the product rule works. So let's rewrite this again. X to the 4 times x to the 7. So in this case, this first one is going to be f, and the second one is going to be g. And remember, it's f prime g plus fg prime. So the derivative of the first one times the second plus the first times the derivative of the second. So if I apply that to this problem, we're going to get dy dx is equal to the derivative of the first one, which would be 4x to the 3, times just the second by itself. So that's the derivative of the, this is important to remember, derivative of the first one times the second one. And now we add that to the first one times the derivative of the second one. So that's going to be 7x to the 6. So that's how you use the product rule. So please make sure that makes sense to you. We have the derivative of the first one times the second plus the first function times the derivative of the second one. And it's always going to be like that when we're doing the product rule. So this, if I multiply these two things together, I get 4x to the 10. If I multiply these two together, I get 7x to the 10. And you see that these are two like terms that can be added together. And you see that we get the same answer. We get the same answer as when we did the power rule. So in this case, you can see that it's a lot easier to use the power rule, and I would recommend you go ahead and use the power rule in this case because you might make a mistake over here. So when would we actually use the product rule? Here's a good function where we're going to use the product rule on. And so once again, in this case, this right here is going to be my f, and this right here is going to be my g. Okay, and once again, it's f prime g plus fg prime. And the most common mistakes people make is they leave out the f or the g. They only take the derivative of f or they only take the derivative of g. So make sure you don't do that. So what is the derivative of f? So we're going to write dy dx equals, what's the derivative of this? Well, I can ignore the 4 because that's a constant, so that just goes away. So the derivative of 9 square roots of x, remember, I'm going to write this. I'm going to not skip a step. Remember, we can write 9x to the 1/2. That's the same thing as 9 root x, okay? But I'm going to put a prime there because I haven't taken the derivative yet, okay? So remember, 9 square root of x is the same as 9x to the 1/2. So we're going to do that times g, which is just x squared, plus, now we take all of f, which is 9 root x, plus 4, times the derivative of g. So the derivative of x squared would just be 2x. Okay, so we're almost there, except I still have one more derivative to do because I didn't want to skip a step and throw you off with the square root. So now let's do that. We do the power rule here, so the 1/2 comes out in front. So we get 9 over 2. And remember, we do 1/2 minus 1. And when we do 1/2 minus 1, we get x to the negative 1/2. And you'll remember that x to the negative 1/2 is putting the square root x in the denominator. So I hope that makes sense. You want to get to a place where in your head you can do the derivative of 9 root x is 9 over 2 over root x. Okay, so 9 over 2 root x. You want to get to a place where you can mentally make that a 1/2, bring the 1/2 out, and then move the square root down to the bottom. Okay, because 1/2 minus 1 is -1/2, which puts the square root down here. Now remember, if you were taking a derivative with square root x in the bottom, it would end up with a power of 3/2 on the bottom, because we'd be adding 1 to the power. Okay, so just be careful. This is x squared plus 9 root x plus 4 times 2x. So that's the answer right there. That's the derivative. Look at how hard this function was. We had a quadratic, x squared, multiplying by a root x with a number in front and an addition in here. And here's the derivative right here. And it's up to your math teacher how much they want you to simplify. I guess you could distribute the 2x here, and you might get the x squared and the root x to cancel if you wanted to. So let's go ahead and do that. As far as I'm concerned, this is pretty much the answer right here. But let's maybe clean it up a little bit. X squared will cancel with the square root of x, which would give us 9/2. And then on the top, we'd have x to the 3/2 plus 2x times 9 root x would be 18. And the square root of x times x would also be x to the 3/2. Plus 4 times 2x would be 8x. So again, I did 2 minus 1/2 to get 3/2. And here we did 1/2 plus 1 to get 3/2. And then 4 times 2x was 8x. So is that any more simplified? I don't know. I mean, I guess you could even add these two like terms if you wanted to. And so you could make that 36/2 right here instead of 18. So 36 plus 9, you'd get 45/2 x to the 3/2 plus 8x. So again, I changed 18 because they both have x to the 3/2. I just changed 18 to 36/2 and then added the fractions. 36 plus 9 would be 45, so it'd be 45/2. So I guess this is the best answer. We're going to use the product rule a lot later in this class. As far as I'm concerned, if you got here, I'm pretty happy because this is the derivative. Maybe just clean it up a little bit. In the next section, we are going to learn something similar to the product rule, which is the quotient rule. So if you like this video, please like and subscribe, and I will see you in the next section with the proof of the quotient rule.